let me introduce Gintare Norkunaite. I hope I have pronounced the name the right way. She's an urban planner from Potsdam Maxam, and she is going to present her work on designing for vital soil in urban areas. Please, Gintare, the floor is yours.
Thank you. Can you hear me?
Yeah.
Yeah. And do you see also the presentation in full screen
Yeah,
mode?
completely.
Yeah. Okay.
Yes.
So then we're all set. So welcome everyone to the session. I will be presenting the results, insights from my recent research project, which is about designing for vital soil in urban areas. First of all, why to care about vital soil? We see that since 1950s, there's exponential increase in human activities, and these socioeconomic trends have the impact on Earth systems. For example, urban population growth results in soil degradation and more intensive land use. Every day in Europe, 184 hectares of land are urbanized. More fertilizer consumption results in soil acidification and reduction of soil biodiversity. Extensive water use lead to salinization and lowering groundwater levels, disturbance of moisture balance. However, vital soils can counteract these negative Earth system trends. Vital soils, especially, can effectively absorb and sequester CO2, also convert nitrogen and make it available to plants, and also support robust plant growth, which is needed to cool the environment through evapotranspiration. And this is especially important in urban areas where we have urban heat island effect with the average higher temperature of 3 degrees, with extreme cases leading to 8 degrees. But what happens with vital soil in cities? There is a scarcity of space and lack of insight what lays underground. Since 1950s, again, we place in subsurface everything that we don't want to see above the ground, such as parking, cables and pipes, waste containers. And in the Netherlands, only since 2006, we are actually mapping what's being placed underground. This leads to overcrowding in subsurface, and yet we still need more space to put installations in the relation to energy transition, such as warmth and cold storage. And these installations alter soil temperature and water system, and therefore integral planning of the subsurface is crucial for sustainable city design. On top of all these issues, cities also have high ambitions to make their environments more attractive and healthy for people to live. And there is a wish to add more green, make cities more nature inclusive, climate adaptive. And all these ambitions require more space underground for the vital soil. So with this, we started then research with this question. So how do you design for the vital soil? And with this research with a large group of experts, which results then in the handbook on designing for vital soil in urban areas, which is publicly accessible online. At the beginning of the research, we were confronted with the question, what is actually a vital soil? And we know that the soil can offer us lots of ecosystem services, but not everything at once. We can choose to focus on productive services such as food, drinking water, energy. We can let soil to carry our buildings and infrastructure, reduce risk such as pollution, or regulate climate and support our ecosystems. And exactly these services of the soil is our focus area in this research for the vital soil. So designing for the vital soil starts, first of all, with understanding the site conditions and the soil system in your project area. Then defining ambitions, and on basis of these two, selecting then which measures you need to apply. And this application of measures process also is iterative. You usually sketch several scenarios until the optimized options achieved. So how do you read the soil as a designer? Our case is Boulevard in Rotterdam, which represents well the situation of soils, vital soils in cities. 90% of this profile is sealed, and only 10% is green, and this is exactly where we can find let's say, the richest part of vital soil. Um, Besides the surface cover, we also look at structures underground, such as lines and points, also how the soil was changing throughout the time, which then also helps us to understand why certain soil layers are as they are. For example, here, the sand layer was added as a filling of the harbor. We also then make a deep soil section to understand water system, groundwater, aquifers, vertical and horizontal water flows, and soil composition. And then we also zoom in into shallow surface, because this is the busiest layer in the subsurface. There we find all the infrastructure, and first 2 meters are the most active with the soil life. So once we know the site conditions, how do we choose the right measures? During the research, during the interviews and workshops with experts, we defined a set of design and maintenance measures, which we categorized in 3 systems: water, organic matter, and infrastructure. Water-related measures, they focus on aim to infiltrate, buffer, store, or treat water, for example, such as a rain garden or biofilter. Organic matter measures, they focus on diversity, working with time, stimulating natural processes, giving space to nature, such as creating generous green patches with a minimum of 3.5 by 3.5 meters. That allows enough space for tree roots, and creating the green patch as a mini ecosystem. But ideally, the bigger the green patch, clustering of the green is the better. In bigger patches of green, we can expect and add higher species diversity, and not only focusing on species, but also combination of plants with different ages. Infrastructure measures, they aim to work with what is there, organized efficiently, designed for multi-purpose, and minimize negative externalities, such as, for example, a parking garage that is also a water storage, or a multi-utility duct where cables and pipes are stacked vertically, and therefore more space remains in a street for the vital soil. When choosing measures, you're often confronted with the question, so which measures perform the best? And therefore, we also looked at 3 topics which are relevant for the city of Rotterdam: climate adaptation, biodiversity, and circularity, and scored these vital soil measures, how they perform per topic. And the bigger the bubble, the circle is, the higher the impact of the measure. Not only we looked at the impact, but also how difficult it is to implement each measure in order to distill so-called low-hanging fruits, so measures which have the high impact and are easy to implement. And then once measures are selected, then we start this iterative design process with multiple options. And it's really your selection of your definition of ambitions at the beginning of design process leads to different spatial outcomes. So you see here 3 different design options for the same street. One is maximizing biodiversity, another is climate adaptation or circularity. And then at the end, the optimized design is chosen, where we also focus on really in drawings to giving a fair representation for vital soil, such as exploring, showing it in the perspective sections, or drawing a plan of the underground where you see tree and plant roots, all the cables and pipes, and underground installations. And all the results of this workshop, of this research, we bundled in the workshop material in order to share this knowledge also externally. Thank you very much.
Anna, you're muted, if I may.
Okay, sorry. Oh, I'm having problems with my mic. So, Joffrey, you are the one who
No,
has.
I was just saying that you were muted.
Yes, but I see that you are the one who has this comment for Gintare. Are you about the concentration of organic matter?
Yeah. Thanks a lot for this presentation. That was very, very nice and very inspiring. I was just mentioning that at the beginning you define what a vital soil is according to you, and I would say maybe you know when you started you said having a lot of organic matter is positive. Well, too many organic matter might also be an issue, and so you just have to be careful. It was really a very small detail. Sorry.
Yeah, you're completely right. The soil health is not it's not, let's say, one benchmark that applies everywhere. We know, for example, for in Dutch we call it kruidenrijke vegetatie. It's let's say biodiverse meadow. That requires quite poor soil.
Yeah.
Yeah, so
Yeah, and yeah, indeed. And just if I may, as a comment, this is really what I like about the concept of soil health. Because, for example, an old person of 80 years old being in a good health is not has not the same, uh, let's say properties like concentrations of elements in blood as a person from 18 years old. So all soils are different, and a soil, like what you just said, a soil from on very specific type of parent materials can have very specific properties, but you can still have a look and is it in a good health or not. And as you just said, in urban context areas, you can try to monitor to improve the properties to enhance the soil health.
yeah, indeed. What is also important in working with city soils, it's not only looking at like what is the situation now, but also how it's maintained. In what is specific for city soil is that, for example, every street it's opened and digged 3 to 10 times a year because somebody just ordered a new high-speed internet, and then again the cable needs to be placed, and all this digging activity distorts these very fragile networks of fungi, which are important to support all the vegetation which is in a street or a park. And therefore, we also, one of the measures that we think about, it's and discuss with the municipality, can we prevent this digging? What are the ways? You can organize infrastructure differently, or you can also create a policy like digging, let's say, no digging time, agreeing on 10 years or something like that. Because we know that specifically for fungi, it has very bad effect, like bacteria. They more or less everywhere, and they can restore pretty quickly. But this fragile fungi network is requiring more attention.
Okay, thank you very much, Gintare. I don't know if you have seen a message on the screen saying that we will come back automatically to the main session, but we will wait until we are automatically sent to the session. So in that time, if you have any other questions, so we are going to, so thank you very much, Gintare. Your presentation was really interesting and clear for me, and I hope for the rest of the audience. So thank you very
Thank you.
much.